Hey guys, and welcome to another deep dive. In this deep dive, we're going to be talking about the delegate design pattern. Now, you might be wondering, hey, wait a minute, we just learned about the MVC, the Model View Controller design pattern, and we're already using it, so why do we need to use another design pattern? Well, remember that the definition for a design pattern is simply just a proven solution to a common problem. And while we're building our apps and programming, we come across lots of different problems, and they often have different solutions. So, what exactly is the problem? Well, let's say that you are Apple and you're trying to design and create some template code, say for a UI text field, so that anybody who comes along and wants to build an iOS app, they don't have to define from scratch all of the properties and methods for a UI text field, because that would take forever. Imagine having to define how a text field would look, whether if it should have rounded corners, what should happen when a user taps in it, detecting user touch, all sorts of things that would just end up taking you years to create a single iOS app. So let's say that Apple creates this UI text field class as a template for you to be able to use. But then we come along and we decide to build a weather view controller. Now, in our weather view controller, we need to be able to detect, for example, let's say we need to be able to know when the text field starts being edited by the user. So we somehow need the text field to notify our weather view controller when it detects that editing has begun. So how would this actually work? Well, then we would need to create in our UI text field, the class definition for our UI text field, a weather view controller object, which is created from the weather view controller class. Well, then we could say weather VC call your text field did begin editing method. And that way we notify our weather view controller and that method gets triggered for us to be able to do something in response to this notification. But you might be able to spot there's quite a few problems here in our logic. Because if we are Apple and we're creating this UI text field class, and we somehow have to know about this weather view controller, which we never created, we know nothing about, and it's something that's going to be created in the future by developers who are building apps using our UI text field, well, that's impossible to know, right? And what do we do if we're trying to support loads of different classes that want to use the UI text field? Say we had another class that wanted to be notified when the text field begins editing. Are we going to create a new object from every possible class that's defined in the future by other people? How do we even do that? So this is kind of the problem, right? We want our text field to be maximally reusable. And in order for it to do that, it can't know about any future custom classes that are created. It has to somehow be able to let any class that uses it be able to know when it detects, for example, the editing has begun, but it can't know the identity of these classes that uses it. So what's the solution? Well, one solution is the delegate pattern. And this is a pattern that Apple really likes to use, which is why we're spending a lot of time to actually talk about it and try to understand it. Underlying the delegate pattern, the technology that really makes it work, is the protocol. And we've already learned about protocols in the last lesson in our Swift deep dive. So we know that we can create a protocol. Say in this case, we could create something called can deal with UI text fields. And we can define in the protocol body some required methods. So for example, every class that says that it can deal with UI text fields should be able to implement this method called text field did begin editing. So now a possible solution that we have using these protocols is, let's say we still have the same situation. Our reusable UI text field that was created by Apple that doesn't know about any other class. And we have our weather view controller, which needs to use a UI text field and also needs the UI text field to tell it when the text field begins editing. In this case, the protocol is actually called the UI text field delegate. And we can make our weather view controller be of that data type by adopting this protocol, by adding it at the end of the class definition, like how we saw in the last lesson, where we looked at how to adopt protocols. So now that our weather view controller is able to deal with UI text fields, now that it's a UI text field delegate, we can now go in our UI text field and define one of its properties as a delegate property. Now, this delegate property has a required data type. In order to set a class or a struct as the delegate of the UI text field, it must conform to this UI text field delegate protocol. So you must be of this data type. So just like in the last lesson, in order to be able to partake in the flying demo of the museum, you had to be of the can fly type. In this case, in order to be the delegate of the text field, in order to be notified when certain things in the text field changes, you must conform to this UI text field delegate. And in the methods of the UI text field, it might, at some point when it detects the text field being interacted with, trigger a method called textFieldDidBeginEditing. And it can safely call this method in the delegate because it knows that in order for a class to have the type UI text field delegate, it had to adopt this protocol. And this protocol has the requirement of implementing this method, textFieldDidBeginEditing. So therefore, it could call delegate.textFieldBeginEditing, not know about what class it is, what it inherits from, what it does, who it is, what's its identity. It knows it can do this because it knows that it has to be of this data type. So now in our weather view controller, in order to adopt this UI text field delegate, we have to have the required implementation for the text field did begin editing. So we have to be able to implement this method because some other class is going to trigger it somewhere else. Now, there's just one final piece of the puzzle. How does the weather view controller actually sign up to be notified by the text field? Well, our weather view controller needs to have a UI text field object. So now that we have a new text field created from this reusable blueprint of a UI text field, we can set its delegate as self, which means its delegate is going to be equal to this current class, the weather view controller. So now that we've got our UI text field, our weather view controller, and our UI text field delegate all defined so we can see what the code looks like, let's see what happens when our app actually runs. What's the sequence of events? Well, the first thing that happens is this line. So we create a new text field from this reusable template of a UI text field. And so now we have this reference to a UI text field. Next, we set that text field's delegate property as self, as the weather view controller. So now this property called delegate in the UI text field is now equal to our weather view controller. And we can do this because our weather view controller adopts the UI text field delegate. So it matches this requirement for the delegate to be of this data type. The next thing that happens is our text field at some point detects that the user has begun editing in the text field. So it triggers this method, which tells the delegate the text field has begun editing. And this method gets called in the delegate, which is of course currently set as our weather view controller, which now triggers this method so that we can do something when the user begins editing in the text field. So now, through the power of protocols and the delegate pattern, we're able to switch out our weather view controller with any other class, and it would work just as well. as long as we're abiding by all the rules and adopting the UI text field delegate, implementing the required methods, we can always get notified when the text field did begin editing. And the best part of it is that the UI text field doesn't have to change. It doesn't need to know about this other class. It doesn't need to know its identity. It doesn't need to know what methods it has, what properties it has. All it needs to know is that it conforms to the data type of the UI text field delegate protocol, which means that it's assured that whatever class it is has a method called textFieldDidBeginEditing, which it can trigger by calling delegate.textFieldDidBeginEditing. Now, this is how we were able to use our UI text field, and we're getting a peek under the hood. But the shame is that because Apple's code, so UI Kit, everything that's, say, our UI text field, UI label, UI buttons, all of these components are proprietary Apple components, which means that the code is not open source. It's proprietary, which means we can't actually see how the UI text field implements the delegate or how does it trigger the delegate.textFieldDidBeginEditing. So we're only seeing a part of the picture here when we use the UI text field. So to be able to get an even deeper understanding of protocols and delegates, let's create our own reusable class, which has a delegate property and can trigger the delegate methods. Let's see the entire picture by creating everything from scratch.